Assalamualaikum warahmatullahi ta'ala jami'an wa barakatuhu. Our research is entitled Compressive Strength of Recycled Concrete in Vertical Construction. I am Nur Salam Il Silungan together with Sharmaris M. Maing, Kadriya T. Angkong, Aliazia M. Musa, Nurhaili Salik, and Yasser Mamulintao.
Introduction. Background of the study: rebuilding and renovation of roads and buildings is a long process, and a large amount of money is required to buy materials such as cement, aggregates, and etc. Usually, after demolition, the concrete pavement is just built up in one place, and because of this, the land built up becomes useless. With regard to the aforementioned issue and problem, we are inclined to recycle gross concrete pavement as a coarse aggregate in coarse mixtures, with the goal of reducing the burden on the people and the government so that there is no need to spend large sums of money on building and renovation. The advantage of recycling concrete is that part of being able to save money, the landfill material will not be wasted. Instead, it can be used for projects to be built in the future. The purpose of this study is to determine the recycled concrete can be used as an alternative for coarse aggregate. Moreover, we're aiming to provide solution and avoid the excessive spending of large amount of money on building innovation project.
Review of related literature. Studies by Wen McLean and Willoughby in 2015 have shown that using recycled concrete aggregates or RCA in a concrete pavements can lead to reduced cost, decreased environmental impacts, and faster project delivery times. Rudnicki and Zarzak evaluate the compressive strength of recycled concrete from the A6 motorway pavement using an N12390-3 column 2019 test process, finding values of 65.8 megapascal for the upper layer and 51.2 megapascal for the lower layer. This meets specification for various types of road construction. Rahal's study found compressive strength values ranging from 36.2 to 40.6 megapascal, while Zhu and Shen's study showed that recycled concrete formed with the different types of the recycled aggregates can achieve compressive and flexural strength equivalent to or exceeding those of the traditional concrete. Research objective. Generally, this study aims to recycle concrete pavement as coarse aggregate to be used in vertical construction. Specifically, it seeks to determine the following: total expenses of the study, compressive strength of the concrete, if recycled material can obtain the standard strength of the compressive strength.
Our conceptual framework showed the input, process, output of our research from the figure above. The materials needed for the research are concrete pavement, cement, and water. We also needed to undergo laboratory tests for its compaction. With these materials and process, we will create concrete using recycled materials. Significance of the study. This study aims to provide solution to some problems such as the excessive amount of money spent on building and renovation project and the waste generated at site where crushed concrete pavement is dumped. In addition, this study aims to provide information and knowledge about determining recycled concrete pavement as an alternative to coarse aggregate in the concrete mixture to be used in a vertical construction.
Scope and limitation. Our study focuses on recycling concrete pavement as a coarse aggregate to be used in vertical construction, specifically as building foundation, walls, slabs, wall, fascias, steps, and stairs. This study is limited on conducting laboratory tests for its compressive strength at DPWH 1st District Engineering Office. This study did not perform laboratory tests for its shear strength and bearing capacity of the concrete since the study focused on recycled coarse aggregate on plain concrete. The shear strength and bearing capacity are determined on reinforced concrete.
For the methodology, the material we use are 4 kg cement, 12 kg recycled concrete, 12 kg fine aggregates, and 3 3/4 pieces of one-wall illustration board. The procedure is: first, crushing the concrete pavement. Second, creating cylinder plastic molder, and the last one is creating a concrete sample or a specimen to be tested at DPWH.
Chapter 3, Result and Discussion. From the Table 1, which is the result of laboratory test for its compressive string. From the table, we tested 6 sample concrete with a dimension of 150 mm as its height by 75 mm as a diameter. From the first 3 samples, we attained 70 load in kilonewton, 75 and 90 kilonewton. For the other 3 sample concrete, we attained 85, 50 and 50 load kilonewton with a curing of 14 days. The standard strength for compressive strength is 2,500 psi. From our test result, we gained 90 kilonewton or 2,956.19. Even though we encountered many error in creating our product, we still managed to attain the standard strength for compressive strength, which is 2,500 psi. Comparing the compressive strength of virgin material and recycled material, recycled material can attain the standard strength for compressive strength. However, virgin material is way more stronger than the recycled material, with just a little difference. Researchers encountered many errors in creating the product, but however, still managed to attain the standard strength for compressive strength. With that, the researcher concluded recycled material can match the virgin material in terms of its compressive strength. The researcher also concluded that using recycled material can reduce the cost spent in building and renovation projects compared to using virgin materials.